This video here is a nice problem coming from the Putnam 2000. Here is the following setup. For all m as an integer, satisfy this following condition. We get 1 is inferior to m is inferior to n. Our goal, we are going to prove GCD of these integers m and n over n is multiplied by n, choose m, is an integer. So we are going to prove this combination is an integer. Okay, before we get started, what's the relationship between GCD and Bayes' theorem? If I'm going to, Bayes' theorem is going to help us a lot here. Let's remind you quickly about the Bayes' theorem. For all m and n as integers, there exist a and b also are integers such that we get this combination linear. M is multiplied by a plus n is multiplied by b, which equals GCD of these two integers m and n, which equals number 1. This is the Bayes' theorem. Okay, it's very nice. So what to do here, I'm simply going to take this formula of the Bayes' theorem and replace it here into this one. So I get the following. So we get m is multiplied by a plus n is multiplied by b all over n is multiplied by n, choose m. So you get this one, n over m, n choose m. So we are simply going to distribute this one out. So I get the sum of two integers, which is m over n is multiplied by a is multiplied by n, choose m, plus the second integer, which is n over n will be cancelled out. I will be left with b is multiplied by n, choose m. It's more simple. Okay, so what we need here, so we are going to prove this one is an integer. We know this one is an integer, but if you prove this one is an integer, we will done. Okay, so let's prove this one. So we get m over n, a is multiplied by m over n is multiplied by n, choose m, which equals a is multiplied by m over n, and choose m is the same as n factorial over m factorial is multiplied by n minus m factorial, like this. Okay, we know this n factorial is the same as n is multiplied by n minus 1 factorial. Also, this m factorial is the same as m is multiplied by n minus 1 factorial. Okay, let's simplify this one out. So we get a is multiplied by m over n is multiplied by n, choose m, which equals a is multiplied by m over n. So this one, it will be n is multiplied by n minus 1 factorial all over m factor m minus 1 factorial is multiplied by n minus m factorial, like this. Okay, so this n will be cancelled out with this n, this m will be cancelled out with this m. I will be left with these things here. So the n minus 1 factorial over m minus 1 factorial is multiplied by n minus m factorial is the same as n minus 1, choose n minus number 1. Okay, like this. Then we multiply it by a. So this one exactly is an integer, because this one is an integer is multiplied by another integer, which is integer. So we have proven this one is an integer. Also this one is an integer, which means the whole thing is an integer. Now we have proven this one is an integer. Now so I have done with this one. Thank you for watching. I will see you next video. Bye.